Yes. Now that we have learned what the arithmetic mean is, I would like to go through with you what another very, very important measure of a sample is, namely the so-called median, which is also somewhat like an average, a mean of data. And now, let's briefly look at the definition and go through it step by step. And here it is important that we have a sample, x to xn, but, and this is very, very important, we assume that this sample is already ordered. That is, from smallest to largest. So x is indeed the smallest value, and xn is the largest value. And what we want to do is, we have our data here. And ultimately what we want to look at is, which value is exactly in the middle in terms of 100 data points? Which value is at 50, so to speak? So let's get a sense of which value lies in the middle of all these numbers. And now there is indeed a problem. There must also be a middle. So let's make a short example. Imagine we have 1, 2, 3 numbers. 1, 2, 3. Then it is clear there is 2001. So a middle, that would be the second. This means that with an odd number, they have a relatively good situation. So they simply just take the exact middle, which in this case would be the median. Now imagine, however, that we have an even number of values, then there is simply no middle. So there is no median. And what we are going to do now is that there are, so to speak, two potential values, namely these two here. And what we do is, essentially, as we see here, we take the mean between 2 and 3. That means in this case 2 plus 3, 2 is the median. Okay, so I'm going to try to clear everything away here again, and then we will take another look at the formula. As we have already seen, there is a middle. When the number of elements is odd, 2001, this is the case here, when we can write n, that is the number of our data, as m plus 1, which means that the whole is odd. And then the middle is, you can think about it again, exactly at m plus 1. However, if the number of elements is even, then we have the situation. So n is 2me, which would be this here. Then we take the two elements that are relevant, which are xm and xm1, and take the half of both, just like in our example with 4 elements, where we took the 2 and the 3. And now a question. What is actually the difference between a median and an arithmetic mean? And when might one be better and the other better? Think about that carefully, and then we will thoroughly discuss it together, in the lecture, together. Now let's look at an example. We have our 5 students from the course 2001 with the scores of 68, 72, 81, 90, and 77. And we are supposed to determine the median, not the arithmetic mean. And now we first sort our numbers 68, 72, 77, 81, and 90. And we know therefore there are 1, 2, 3, 4, 5 in terms of the scope. That means we have an odd situation and there is exactly the middle. And you can certainly see it. The middle is exactly the number 70. So, and that makes sense because if we look at it, n is equal to 5, which means 2, 2, 1. This means our m, esos, eos is equal to the second. And if we look at the formula again, we know that the median is x. So we know we are at xm first. M was 2. So our solution is xm1 which is nothing other than x, and that was 70. Well, that was the median. And in the next chapter or the next video, we want to look at how we can not only examine the middle with this idea, but also with any arbitrary percentage. For example, the value at the 0.75 or at the 75th percentile. And this will lead us in 2001 to the concept of quantiles, or so-called p-quantiles. It's a bit more complicated, but intuitively it's actually quite clear again. Until then, 2001.